All right, let's get into it. Today, we're going to pull back the curtain on something we all use every single day, video streaming. We're actually going to build our own video server using Go, and you're going to see how a task that sounds super complex is, well, surprisingly straightforward. Let's do this. So think about this for a second. You're watching a long YouTube video, or maybe a movie, and you want to jump way ahead. You grab that little dot on the seek bar, drag it to the 45-minute mark, and poof, it just starts playing. But how? You haven't downloaded the first 44 minutes of the video, right? It feels like magic, but I promise you, it's not. It's just some really, really clever engineering. You know, back in the early days of the internet, things were painful. If you wanted to watch a big movie file, say 10 gigs, you had to sit there and download the entire thing before you could even think about hitting play. Forget about skipping ahead, no instant gratification. It was just this massive, inefficient process. And what a waste of time and bandwidth, especially if you just wanted to see one specific scene. So what's the secret sauce? It's something called HTTP range requests. And this right here is the core idea we're going to unpack today. It's really simple, actually. Instead of your video player asking for the whole movie at once, it can say, hey server, you know what? Just give me the chunk of data that corresponds to the 2-minute mark all the way up to the 3-minute mark. It's asking for a specific piece, not the whole pie. And why is this such a big deal? I mean, it's a total game changer. For one, it enables seeking. That's the magic we were talking about. You can just jump anywhere. It also makes playback super efficient. Your player only needs to download the next few seconds of video, just enough to stay ahead of what you're watching. And maybe most importantly, it saves a ton of bandwidth. I mean, think about it. No more wasted data on the parts of a video you decide to skip. It's a win-win for you and the server. So let's break down that conversation between the client, your video player, and the server. I love this analogy. Think of it like going to a library. The old way was like saying, I need to check out this entire 1,000-page encyclopedia. You had to lug the whole thing home. But the new way with range requests is like walking up to the librarian and saying, hey, can you just photocopy pages 520 through 525 for me? The client asks for a specific range of bytes, and the server is smart enough to just hand over that little piece. Simple as that. Okay, so we get the what, right? We understand the theory. We need a server that's smart enough to handle these special requests for little pieces of a file. So the big question is, how do we actually build one? Well, this is where the Go programming language comes into the picture and honestly makes our lives incredibly easy. And you're not going to believe this. Go has a single built-in function that does all the heavy lifting for us. I'm serious. The Go standard library is kind of famous for being powerful and batteries included, and this http.ServeContent function is a perfect example. It automatically figures out what the range request is asking for and sends back just the right chunk of the file. We don't have to write any of that tricky logic ourselves. It is absolutely brilliant. All right, before we dive into the code itself, let's just quickly map out our project. It could not be simpler. We just need one Go file, we'll call it main.go, then we'll make a static folder, and inside that, a videos folder. And that's where we'll stick our video file. That's the whole setup. Super nice and clean. Okay, take a look at this. This is the entire server. And no, I'm not kidding you. It's basically 3 lines of code that do all the work. So let's just walk through it real quick. First, we create a file server that serves files out of our static directory. Simple. Then, the next line, we tell our server that anytime a request comes in for a URL starting with /videos/, it should let our file server handle it. That strip prefix part is just a clever way to tell it to look for the file inside the static folder without the /videos part. And finally, we just start the server up and tell it to listen on port 8080. That's it. We have a server. All right, theory's over. Let's actually see this thing in action. Getting this up and running is just as easy as the code was to write. Just save that code as main.go, make those static and videos folders, drop any old MP4 file you have lying around into that videos folder, then pop up in your terminal and just type go run main.go. Boom! Your very own video server is now live on your computer. Okay, here we go, the moment of truth. Open up your favorite web browser and just go to that local address, localhost 8080/videos/ and then whatever your video file is named. If you did everything right, your video should just start playing. But here's the cool part. Go ahead, click around on the seek bar, jump to the middle, jump to the end. See that? It works perfectly. Instant seeking. All right, so it works. We see it working in the browser. That's cool. But, you know, we're developers, right? We need proof. How can we really be sure that what's happening under the hood is what we think is happening? How do we prove our server is actually having that clever conversation about partial content and isn't just secretly sending the whole file? Well, to do that, we're going to use a fantastic command line tool called curl. If you haven't used it, it basically lets you pretend to be a web browser, but from your terminal. We're going to send a request to our server, but we're going to add a special header to it, a range header. And we're going to specifically ask for just the first 1024 bytes of our video file. And this is what our server sends back. Now you see a bunch of text here. These are the response headers. There's some interesting stuff like the content range and the content length, but there is one specific line, one little number in here that tells us everything we need to know. 206. That's the one. That little number is our smoking gun. This is the big aha moment. It's the HTTP status code and it's everything. See, that 206 partial content status code is the server screaming back at us. Success! I got your request for just a piece of the file, and here is that exact piece you asked for. This is so important. If it had sent back a 200 OK, that would mean it was sending the whole file. But it didn't. It sent 206, and that's our absolute confirmation that our little Go server is doing its job perfectly. Okay, so we did it. We've got a working video server that understands the absolute fundamental building block of modern streaming. That's huge. But it kind of makes you wonder, right? How do you get from this simple little server to a global giant like Netflix or YouTube? Well, this is where you start building on top of that solid foundation. Our little server is the core concept, but the big players add a whole bunch of layers. For instance, they add authentication, to check if you're actually a paying subscriber. But the really big one is something called adaptive bitrate streaming, or ABR. This is a game changer. Instead of having just one massive video file, they encode the video into multiple different quality levels, like 480p, 720p, 1080p, 4K, and then chop each of those versions into tiny little chunks, maybe 2 to 4 seconds long. Your video player is smart enough to check your internet speed and then request the chunks from the highest quality stream your connection can handle, without buffering. It's constantly adapting. And to make this work globally, they use content delivery networks, or CDNs, which are basically thousands of servers all over the world that store copies, or a cache, of those chunks. So when you hit play in Tokyo, you're getting the video from a server nearby, not one all the way back in California. But here's the secret. Underneath all that complexity, it's still just a bunch of servers, just like ours, serving tiny little files. And there you have it. In literally just a few lines of Go code, we've implemented the absolute core technology that powers every single major video platform you use. It all comes down to this one simple idea, serving just a piece of a file instead of the whole thing. Understanding that is the key. So now that you know the secret, what are you going to build with it?